Okay. So 3-4 is called implicit differentiation. Sounds very good. So, so far, everything that we have done has been y equals with an x. Okay, so that's called explicit equations. Okay, so when you have the y equal to the x. Implicit is when you have an x and a y on the same side of the equation. Okay, so do you see where I'm looking at? Like this equation there is the equation of a circle. Oh, we're lagging. So that x squared plus y squared plus 1, that's a circle. Okay, then they can get even more complicated and so forth. So anytime you have an x and a y on the same side, that is implicit differentiation. Okay, so they give us a nice little procedure of how to do this, okay, which only entails 4 little steps. Piece of cake. Okay, so the first step is that you're going to differentiate both sides with respect to x. Okay, so at some point we're going to start changing variables and we're going to start using like r's and t's and things, yeah, in respect to time. That's when we start doing more like physics stuff. So it's always important that you know what variable you're deriving everything in terms of. Okay, so the piece that's really, really important to that is if I'm deriving an equation with respect to x, anytime I derive any other letter, I have to say dy dx, dr dx. Okay, we never have said dx dx, okay, which we technically have been doing, but dx dx is just the value of 1, right? Dx dx would cancel out and we call it 1. Okay, so when you derive whatever you happen to be deriving, you will have to add on a hook-on factor when you're deriving in terms of the y. And then all you do from there is you basically isolate your y stuff. So you get all the y's on one side and then solve for dy. Okay, the rest of it is basically algebra. Okay, so for warm-up, they start with some explicit equations. Okay, so question number 1 is an explicit formula. So if I was going to derive this in terms of x, what is the derivative of y equals x? Okay, so technically, if I wanted to be very careful about the way I write the notation, okay, if I derive y in terms of x, my y becomes dy dx. Okay, in the past we've been writing like that y with a little apostrophe, which means the same thing as dy dx. It's just quicker to say. Okay, so when I derive the x, I technically am doing the derivative of x, which is 1 dx dx. Okay, so that is like the most amount of work that you could possibly say, okay, which we have just been saying, oh, well, that's just 1, right? Okay, so for question number 2, how would you say the derivative of y equals x squared? Dy dx, good. 2x dx dx. Yeah, and we're not going to say dx dx, so we'll always assume dx dx is technically 1. So if you want, you can say it, but then we would then have to simplify one more step and say, oh, well, that's just 1. So we'll just go as far as this right here. Okay, what about number 3? How would you go about doing 3? Dy dx equals, so what rule are you doing here? Okay, so we haven't learned, have we learned, yeah, we learned chain. Can't remember with calculus in there. So we can do a chain rule, right? So where you throw the 2 out in front, leave the inside, and then multiply by the hook-on factor. Okay, so it's going to be the 2 out front. The quantity stays the same. What's my new exponent? To the first. And then what is the derivative of the inside? 2. Okay, which If they said simplify, I would simplify it, but when it doesn't say simplify, I stop and I don't make any more mistakes, right? Okay, bless you. All right, what about number 4? So now we're getting into notation. Okay, so we have this piece of f of x that's being squared. Okay, which rule are we going to use for this one? Not product. The chain. You could actually do a product and call it f of x times f of x because that is f of x squared. So you could do a product rule. But they're trying to get you to do a chain rule here. So dy dx. Okay, the 2 is going to go out front. The inside stays the same. And then we multiply by the derivative of the inside, which is the derivative of f of x. Okay. All right, so here's question number 5 where things get a little bit more exciting. Okay, so now we still technically have an explicit equation. Okay, it's not completely isolated for the y, but we can treat it as doing both sides. Okay, so on my left side, what is the derivative of x? 1. Okay, and on my right side, what is the derivative of y squared? 2y, what else? dy dx. Thank you. Okay, so just so you know, you can write that dy dx, or it is also fair game for you to write this as 2y times y prime. Okay, whichever one floats your boat, just realize that dy dx is an equivalent statement as y prime. Probably from now on I'm going to use y prime just because it's less writing. Okay, and it just is less confusing, I think, once you start working with dx's a lot. Okay, so here is an implicit equation. We have an x and a y on the same side of the equation. Okay, so I'm going to go ahead and derive each term independently, and then I'll just isolate the dy dx, or y prime in this case. Okay, so starting with the x squared, what is the derivative of x squared? 2x. So I have 2x. Okay, what is the derivative of 2y cubed? 6y squared dy dx, or y prime, good. I'm going to write y prime because it's a little bit faster, right? Okay, third term, what's the derivative of 3x? 3, good. And the derivative of 6 on my other side is 0, good. So now, all I'm going to do at this point is now isolate the y prime. Okay, everything else is going to get pushed to the other side. So how would you isolate y prime? Yeah, so good. So everybody okay with me subtracting 2y and the 3 at the same time, and then dividing by the negative 6y squared? So some of you guys can probably do that in one step, which is totally fine. Okay, and then I always want to check to see if I can simplify, especially if it's on a question that says simplify. Can I? Yeah, with the numbers. Can I? Can I divide all 3 of those numbers by something? No. No. Close though. Okay, so that is all you do for implicit. Okay. All right, now question number 4, same idea. The only difference now is that we have a point. So it says find the slope of the tangent line. So anytime I'm finding a slope, I'm going to find the derivative, and then I just plug the point in. Okay, so this time I'm going to actually have an x and a y. So this y is actually going to come into play for the first time. Okay, so when I derive it, what is the derivative of x squared? 2x, good. What is the derivative of 4y squared? Good. 8y times y prime. And derivative of 25 is 0. Okay, what do I do next? Solve for the y prime. So how would you solve for y prime? Good. So subtract 2x and divide by 8y. So y prime is, can I go ahead and say that 2 over 8 is going to reduce to 1/4? Everybody okay with what I did there? Okay. Now, so for me to find the slope, I'm going to plug in that point that they gave to us, the 3, 2. So check out the notation that you use when you plug in a point. So you just kind of have like a little subtext. And so you can see that now I'm plugging in the 3, 2 into that derivative piece. So I'm going to replace every x with a 3 and every y with a 2. And this will lead me to the slope of the tangent line. So negative 3/8. Okay, so did it say, it says find the slope of the lines tangent to and normal to the graph. Do you guys see how it says, ask me technically 2 questions here. It says find the slope of the tangent line and the normal. Whoa. So our tangent line is just going to be the given. Okay, do you guys remember how to find the normal? Opposite reciprocal, good. So the normal line slope is going to be 8/3. Okay. Is that it? That seemed too easy. Okay. Okay, so question number 3. Doing basically the same thing. I'm going to guess this is going to get a little bit more exciting here. Okay, so same thing. What is the derivative of x to the 3rd? 3x squared, good. Ah, here it is. This is the exciting part. Okay, do you see how that second term has an x and a y? Okay, technically what is happening is there is a multiplication happening between the x and the y. Okay, so I have a 2x and I have a y. So when I have 2 things being multiplied and I'm deriving, I have to use the product rule. Okay, now the really tricky part, there's like 2 tricky parts in here, is that not only am I going to have to do a product rule, but do you see how there's that nasty negative in the front? Okay, so when I do a product rule, I'm going to put everything that I do product rule kind of in parentheses so I don't lose that negative. Okay, so I'm going to say my first term is the 2x and my second term is the y. So I'm going to do a first d second plus second d first. Okay, so first is my 2x. D second, what is the derivative of y? Y prime. Plus my second, which is y, d first. What is the derivative of 2x? 2. Whoa, sorry. 2. Okay, so I'm going to end that parenthesis, and then we'll distribute that negative here shortly. Okay, so moving on now to my third term, what is the derivative of y cubed? Okay, so plus 3y squared y prime. And on the other side, derivative of 5x is 5. Good. Okay, so now my goal is to isolate my y prime. And do you see how I have 2 terms with y prime? Yeah. So I need to get both those on the same side, everything else to the other side. I'm going to start by just distributing that negative through first. And then we'll do that second. So it'll be minus 2y plus 3y squared y prime equals 5. Okay, so I'm going to get rid of the 3x squared and the negative 2y. So I'm going to have 2xy prime plus 3y squared y prime equals 5 minus 3x squared plus 2y. Everybody good with that step there? So just sending those 2 terms to the other side. Okay, so now how am I going to isolate that y prime if I have it in 2 different terms? They're not like terms. There you go. We're going to pull it out like a greatest common factor. Okay, so we're going to pull the y out, the y prime out, and then what's left over is going to be stuck in parentheses. Okay, so if I pull y prime out, what's going to be left out of the first quantity? Negative 2x. And what's left out of the second quantity? 3y squared. Good. Okay, my right side doesn't get touched. We didn't do anything there. Okay, so now I have that y prime being multiplied by the quantity. How am I going to get rid of it? Divide it to the other side. Good. So my y prime is going to equal 5 minus 3x squared plus 2y divided by negative 2x plus 3y squared. So that is my first derivative. Okay, if we go back up to the directions, it says find dy dx, which we just did. Now we got to evaluate at the given point. So now we're going to plug in the points 1, 2, and simplify. So every time I see an x, I'm writing a 1 in its place. Every time I see y, I'm replacing it with a 2. So if we simplify that, we have, let's see, on the top we have 5 minus 3. Wait, where are we looking at?
Denominator negative 2.
Negative 2. Oh, the x is a 1. Ooh, good catch. That would be a different number. Thank you. Okay. Okay, so we got 5 minus 3, which is 2, and then 2 plus 4. So would you agree with a 6 on the top? And then on the bottom, negative 2 plus 12, right? Over 10. So that would reduce to 3/5. So that would be the slope of the equation at the point 1, 2. Not bad? So just so you know, you're going to see that question a lot. It's going to be on the next test and probably the next test after that. And then maybe even the next test after that. So they love this piece with that minus product rule. Okay, is this our last question, number 4?
I hope so.
I think it is. All right. So, this one says find y prime, so double prime. So we're finding the second derivative, and it says in terms of y. Okay, so what does that mean?
dy dy.
So now we're deriving it, yeah, in terms of y's. Okay, so now we're going to do dx dy. Is that right? I don't know if that's right. It seems weird to me.
Oh, wait, no. We did, yeah.
In terms of y. Oh, yeah, so when we're finished, it's all going to be in terms of y. Oh, I see what's going to happen here. Okay, so we're going to just y prime it. And then at the very end, we want everything to be y's. So we're still not deriving it in terms of y. We're just going to write the equation in terms of y only. So we'll talk about that second step. This part right here, last. Okay, so deriving it first, what is the derivative of x squared? 2x. Okay, what is the derivative of y squared? 2y, y prime, good. And derivative of 3? 0. Okay, so at this point, I want to isolate my y prime, and then we're going to derive it again. So that's how you get to the second derivative. So first I got to isolate my y prime. So how would you isolate y prime? Okay, so subtract 2x, divide by 2y. So can I go ahead and say that's negative x over y? Did I jump too fast there? 2's cancel. Okay, so now here comes the part where I do a second derivative. Okay, so which rule am I going to have to do if I have a top and a bottom? Good. Okay, so now this is going to be quotient rule. Okay, so when I derive the y prime, what's the derivative of y prime on the left side? Double prime, right? Okay, so I derive the left side, don't forget that part. Okay, so now on the right side I'm doing quotient, so it starts with the hoe. So my hoe is y. So hoe d high, what's the derivative of negative x? Negative 1. minus the high d ho. What's the derivative of y? Y prime. All over y squared. Okay, so if we simplify that really fast, we're going to have negative y, and we'll call it plus x y prime over y squared. Okay, so at this point, I have an equation that's in terms of an x, a y, and a y prime. Okay, it has three pieces. Okay, so what we're going to do is we are going to replace the y prime, so see this piece right here, with what it's equal to. Okay, so that's going to give me negative y plus negative x over y squared Oh, is that what they're talking about?
Yeah.
Okay, so now if I simplify that, that would give me negative y, and then would you see that it turns into a minus? Minus x squared over y, all over y squared. Okay, so we're getting closer. At this point, I'm now in terms of x and y, so I still have an x in there that I have to replace. Okay, so what I could do is if I go back to my very original equation, you guys see my very original way up there? Do you guys see how I have an x squared down in my bottom? And if I went back to my original, it would be pretty easy to take this equation right here and slightly alter it so it said x squared equals. What would it say? X squared equals what? Yeah, 3 minus y squared. Same thing. Right? So now what I can do is now replace this x squared with 3 minus y squared. So my last step here is going to be y minus 3 minus y squared over y. This is over a lot of y's. Over y squared. What's that? So technically, this is an equation that's in terms of y. It is not fully simplified. So, yeah, I mean, it's up to you how far you want this to go. Y squared over y minus.
We're going to do it, exactly.
I'm just going to keep going, but. I'm just getting a common denominator.
We can stop in the first section.
So just getting a common denominator, and then these cancel. So you end up with negative 3 over y. And if you divide by y squared over 1, that's the same as multiplying by its reciprocal. At the end of the day, you end up with negative 3 over y cubed.
But you see,
if you fully simplify.
do we have to fully?
So if it does not say simplify, then you could have stopped right, where was that spot? Right here where you replaced all of the y's. Okay, so once you no longer have x's and y primes, you could be done. Okay. Okay, that's it, right? Okay, so you guys have the rest of class to work.